Hello everyone. The endless depths of space are one of humanity's greatest secrets waiting to be discovered. When we look at the sky, we encounter the twinkling light of billions of stars. However, there are even greater, and mysterious beings lurking in the universe. In this documentary, you will step into the fascinating world of black holes and discover the deepest secrets of the universe. Black holes are objects in space that have an extraordinarily dense mass. Black holes are regions where the gravitational force is extraordinarily strong due to their density. This gravitational force can be so great that it can even trap light. The most basic feature of black holes is that they have a certain radius, called the Schwarzschild radius. The Schwarzschild radius is a critical point for black hole formation, and an object with a mass density exceeding this radius can become a black hole. Gravity around black holes is so strong that neither light nor any matter can escape from it. Therefore, anything that falls into a black hole is absorbed by the black hole and disappears. This point is called the event horizon, and determines the outer boundaries of black holes. Black holes can vary in size. As their mass increases, their size and gravitational forces also increase. Supermassive black holes, with masses millions of times greater than the mass of the Sun, can be found at the centers of galaxies, while smaller mass black holes can be formed by the collapse of stars. Black holes are also associated with accretion disks formed by matter orbiting around light. Matter rotating around black holes can emit high-energy rays and particles as a result of friction and condensation. This process can cause the bright and energetic phenomena observed around black holes. Black holes play an important role in understanding many different processes in the universe. For example, black hole mergers can be the source of gravitational waves and help understand cosmic events. Additionally, the relationship of black holes with concepts such as the expansion of the universe, galaxy formation and dark matter are still actively researched topics. Black holes continue to be an important focus of studies in physics and astronomy. Observations, simulations, and theoretical studies help us understand the nature of black holes, their effects, and how they are distributed in the universe. In addition, the relationship of black holes with quantum mechanics and their compatibility with basic physical principles such as information conservation is an active area of research. Another feature of black holes is that they trigger the curling of spacetime and the formation of gravitational waves. The merger of black holes can occur as a result of the supernova explosion of massive stars, and gravitational waves are emitted during this merger process. Gravitational waves can be detected by observatories that detect gravitational waves, such as LIGO and Virgo. This discovery provided important evidence about how black holes create effects in the universe. Due to the effects of black holes on spacetime, the flow of time also changes. Due to the gravitational force of black holes, time passes more slowly near the black hole. This effect is called time curvature, and is explained by the general theory of relativity. This phenomenon means that time moves at a different speed around the black hole. Black holes also play an important role in large-scale cosmological processes such as the expansion of the universe, galaxy formation and evolution. Supermassive black holes are found at the centers of galaxies and attract matter around them. This process is a critical factor for galaxy formation and evolution. Black holes are also associated with mysterious concepts that affect the structure of the universe, such as dark matter and dark energy. Our knowledge about the nature and properties of black holes is obtained through a combination of observations, simulations and theoretical studies. Large telescopes, spacecraft, and gravitational wave detectors are used to confirm the existence of black holes, study their properties, and understand how they impact the universe. In addition, the relationship of black holes with quantum mechanics and their compatibility with basic physical principles such as information conservation is also an active research area. Another feature of black holes is that they trigger the curling of spacetime and the formation of gravitational waves. The merger of black holes can occur as a result of the supernova explosion of massive stars, and gravitational waves are emitted during this merger process. Gravitational waves can be detected by observatories that detect gravitational waves, such as LIGO and Virgo. This discovery provided important evidence about how black holes create effects in the universe. Due to the effects of black holes on spacetime, the flow of time also changes. Due to the gravitational pull of black holes, time passes more slowly near the black hole. This effect is called the curvature of time and is explained by the general theory of relativity. This phenomenon means that time moves at a different speed around the black hole. Black holes also play an important role in large-scale cosmological processes such as the expansion of the universe, galaxy formation and evolution. Supermassive black holes are found at the centers of galaxies and attract matter around them. This process is a critical factor for galaxy formation and evolution. Black holes are also associated with mysterious concepts that affect the structure of the universe, such as dark matter and dark energy. Our knowledge about the nature and properties of black holes is obtained through a combination of observations, simulations and theoretical studies. Large telescopes, spacecraft, and gravitational wave detectors are used to confirm the existence of black holes, study their properties, and understand how they impact the universe. Black holes are one of the most mysterious and fascinating formations in space. Since their discovery, they have created great excitement in the scientific world and opened a new window for humanity to understand the nature of the universe. The discovery of black holes has been a revolutionary step in the fields of astrophysics and cosmology. The first clues to the existence of black holes emerged with the development of Albert Einstein's general theory of relativity. This theory helps us understand the concept of gravity and the curvature of spacetime. But the real discovery of black holes took place in the second half of the 20th century. In the 1960s, astronomical observations and mathematical calculations suggested that stars could turn into black holes as a result of supernova explosions. This theory was supported by the first neutron star discovered by radio signals in 1967 by Jocelyn Bell Burnell. Neutron stars have properties similar to black holes, with their extreme density and strong magnetic fields. The first black hole observation was made in 1971. An X-ray source called Cygnus X1 has caught the attention of astronomers. This source indicated a black hole orbiting a star and creating a large gravitational effect. In 1974, the fact that Cygnus X1 rotates with the star and has a certain period proved the correctness of the black hole theory. The discovery of black holes was a major step forward in understanding the nature of the universe. Black holes are important not only for their fascinating structure, but also as an important factor shaping the evolution and structure of the universe. Supermassive black holes located at the centers of galaxies affect the formation and evolution of galactic structures. The discovery of black holes has also led to a significant advance in physics and cosmology. Black holes can serve as a laboratory for understanding and unifying the contradiction between general relativity theory and quantum mechanics. The densities and time curvatures inside black holes can function like a laboratory that tests the fundamental rules of the universe. Therefore, the discovery of black holes is an important step towards understanding quantum gravity and the structure of the universe. The importance of black holes is of great importance not only in scientific terms, but also in terms of technological and space exploration. Learning more about the nature of black holes could play an important role in future space travel and the safety of astronauts. Additionally, the energy potential of black holes may also be instrumental in the search for alternative sources for future energy production. Black holes also provide important clues about the formation and evolution of the universe. We can find answers to questions such as how the universe was shaped after the Big Bang and how galaxies were formed by examining black holes. How black holes affect the large-scale structure of the universe could lead to a better understanding in the field of cosmology. The connection between the expansion of the universe and black holes is an important issue that has been researched and studied for a long time in the fields of cosmology and astrophysics. This connection is of great importance for understanding the structural evolution of the universe and understanding how black holes affect the expansion of the universe. Expansion of the universe. In the early 20th century, with the discovery of astronomer Edwin Hubble, it became clear that the universe was expanding. By observing the redshift of distant galaxies, Hubble revealed that galaxies were moving away from each other and the universe was expanding. This discovery showed that the universe does not have a static structure and is constantly expanding. In general, the expansion of the universe is described as a process in which every point of space moves further away from each other. The fact that galaxies are moving away from each other means that space itself is expanding. This expansion must have occurred more rapidly the further back we go into the history of the universe. The Big Bang theory is a theory that attempts to explain the origin of the expansion of the universe. According to this theory, the universe was in a dense and hot state at some point about 13.8 billion years ago. Then, at this point, a massive explosion occurred and the universe began to expand. This expansion enabled the shaping and formation of today's universe. Black holes are known as structures in the universe that have large masses and are characterized by intense gravitational force. Black holes have a powerful gravitational field that warps the fabric of space, capturing even the matter and light around them. The connection between the expansion of the universe and black holes aims to understand how black holes affect the space around them and how they can influence the expansion process. However, this topic is still an active area of research and is not fully understood. Some theories suggest that black holes could slow or even stop the expansion of the universe. The gravitational effect of black holes is associated with dark matter and dark energy, which hold galaxies together. Black holes can slow or stop the expansion of surrounding space by attracting nearby matter. On the other hand, there are different theories about how black holes affect the expansion of the universe, depending on their size and properties. For example, it is thought that supermassive black holes could accelerate the expansion of the universe. This is explained by the fact that black holes release energy by attracting the matter around them, and this energy has the effect of accelerating the expansion of the universe. Additionally, the influence of black holes may also play a role in density fluctuations and structure formation in the early universe. The gravitational pull of black holes can influence the formation of galaxies and galaxy clusters by causing matter and energy to condense. Observations and simulations are used to learn more about the effect of black holes on expansion. Space telescopes and big data analysis techniques are helping us better understand the relationship between the expansion of the universe and the distribution of black holes. Space and time. Black holes. The concepts of space and time are two important concepts that are fundamental to understanding and describing the physical world. While space refers to a place where objects exist, move and are positioned, time refers to a process in which events occur sequentially. Space and time include coordinate systems and mathematical expressions used to determine the location and time of physical events. Albert Einstein's general theory of relativity proposes that space and time interact with each other and that massive objects cause the curvature of spacetime. Based on this theory, black holes are the points where space and time are most dense and curved. Black holes are regions formed as a result of the collapse of a star by its own gravitational force. A black hole has a mass density so great that it profoundly warps the space around it. altering the normal flow of time and light. It is thought that it is impossible to reach a point inside black holes. This point is a region at the center of black holes where the gravitational force becomes infinite, and this point is called core, or singularity. The curvature of space around black holes prevents light from traveling linearly. Therefore, black holes are thought to have an event horizon. Something that enters the event horizon falls into the black hole and can no longer return. The radius of this event horizon varies depending on the masses of the black holes. The existence and properties of black holes are better understood with the general theory of relativity and studies on the radiation of black holes. Studies led by Stephen Hawking have revealed that black holes emit radiation and that this radiation can shrink black holes over time. Black holes help us understand basic physical concepts such as the nature of the universe, the flow of time, the curvature of space, and the expansion process of the universe. Additionally, the existence of black holes may also have an impact on the formation of galaxies and the structural evolution of the universe. Black holes can influence the formation of galaxies and galaxy clusters by pulling in nearby matter. It also contributes to the understanding of important processes such as black holes, energy transfer and matter cycle in the universe. The impact of black holes on space and time results in a large warping of time and warping of space. This means that time moves slower and light bends. The gravitational force of black holes is so strong that they create a gravitational well from which even light cannot escape. This causes the space around black holes to be dark and mysterious, which is why they are called black holes. The existence of black holes has been a source of great curiosity and discovery in the field of cosmology. It is thought that there may be black holes of many different sizes and masses in the universe. Supermassive black holes are large black holes found at the centers of galaxies and play an important role in galaxy formation and evolution. Small black holes are black holes that are formed as a result of the collapse of stars and have smaller sizes. Black holes are an important research topic to unravel the secrets of the universe, understand mysterious concepts such as dark matter and dark energy, and understand the formation and evolution of the universe. Astronomers and astrophysicists use observations, simulations and mathematical modeling to learn more about the formation of black holes, their size, effects and impact on universal processes. The discovery and understanding of black holes provides us with greater understanding and knowledge in our journey to unravel the mysteries of the depths of the universe. This field will continue to be an area where scientific research continues, discoveries are made, and there will be more enlightenment in the future. Schwarzschild radius and black holes. The Schwarzschild radius is one of the fundamental properties of black holes. This radius refers to the point where the mass density of an object is equal to the libration speed of the gravitational force. This concept, discovered by German physicist Karl Schwarzschild in 1916, plays an important role in the general theory of relativity. According to the general theory of relativity, the gravitational force of an object changes the path of surrounding objects by bending the space-time fabric. If the mass density of an object is so great at a certain point that a point is formed where the escape velocity is equal to the speed of light, this point is called the Schwarzschild radius. The Schwarzschild radius defines the radius of the limiting region of black holes, also known as the event horizon. Anything that gets inside the event horizon can no longer escape the black hole. The radius of the event horizon varies depending on the masses of black holes. If an object falls within the Schwarzschild radius, there is no longer any way out for that object and it is absorbed by the black hole. The Schwarzschild radius is an important parameter when determining the properties of black holes. If an object has a radius smaller than the Schwarzschild radius, that object is considered a black hole. The Schwarzschild radius helps us understand the size of black holes and the process of black hole formation. Black holes have a strong gravitational force that affects matter and energy falling within the Schwarzschild radius. This gravitational force warps the fabric of spacetime, creating an environment where time slows down and light bends. Therefore, the Schwarzschild radius is considered one of the fascinating and mysterious properties of black holes. The Schwarzschild radius of black holes is a fundamental tool in determining the masses and sizes of black holes. This radius helps us understand the gravitational force of black holes, the size of the event horizon, and the impact area of black holes. The Schwarzschild radius is an important parameter for delving deeper into black holes and understanding black holes, one of the densest and most mysterious regions in the universe. The Schwarzschild radius also affects the formation of black holes. In the final stages of a star, nuclear reactions inside the star cease and the gravitational pull begins to compress the star's own mass. If the star's mass density exceeds its Schwarzschild radius, the star collapses to form a black hole. In this process, the outer layers of the star explode and condensation occurs in the inner part. Thus, a singularity, a dense mass point, emerges in the region within the Schwarzschild radius. The Schwarzschild radius also determines the event horizon of black holes. The radius of the event horizon is equal to 2 times the Schwarzschild radius. Light or matter falling inside the event horizon can no longer escape the black hole and is irreversibly absorbed by it. In the region outside the event horizon, matter or light may revolve around the black hole, causing different phenomena to occur. The Schwarzschild radius and black holes give us important clues about the nature of the universe and physical processes deep in space-time. Black holes play a critical role in understanding fundamental concepts such as the flow of time, the behavior of light, the curvature of spacetime, and the general structure of the universe. The Schwarzschild radius is a tool used to understand these depths and unravel the mysteries of black holes. Research on black holes and the Schwarzschild radius continues in the fields of physics and astronomy. The existence and properties of black holes are being tried to be better understood by using telescopes, radio observations and similar tools. In addition, scientists continue to work on concepts such as the internal structure of black holes and singularity. The existence and properties of black holes help us understand fascinating and complex physical processes deep within the universe. The Schwarzschild radius is a fundamental concept in this understanding and plays a key role in understanding how black holes create effects in the universe. Black holes affect the matter and light around them, causing various phenomena. Around a black hole, the gravitational force is so strong that not even light can escape. Therefore, black holes create a gravitational well into which light is absorbed and nothing can escape from it. This effect is called blackbody radiation. Blackbody radiation causes the space around black holes to become dark and mysterious. Black holes also affect the flow of time. Due to the gravitational force of black holes, a region is formed where time moves slower. This effect does not mean that time stops around the black hole or that it can flow backwards, but that time moves at a different speed there. This phenomenon is called time curvature. Black holes can also cause interesting events due to the influence of nearby matter. If a star interacts with a black hole, some of the matter is absorbed by the black hole and the rest is ejected out in the form of high-energy particles. This process leads to disk-shaped formations called accretion disks, in which bright, hot material orbits the black hole. Accretion disks may be the source of the bright and energetic galaxies observed around black holes. Black holes can also influence large-scale processes such as the expansion of the universe and galaxy formation. Supermassive black holes are found at the centers of galaxies and attract matter around them. This process is important for galaxy formation and evolution. Black holes are thought to be associated with mysterious concepts such as matter transfer, energy transfer and dark matter in the universe. Observations, simulations and theoretical studies continue to better understand the role and effects of black holes in the universe. Large telescopes and spacecraft are used to confirm the existence of black holes and study their properties. At the same time, research on theoretical topics such as general relativity and quantum physics helps us better understand the nature of black holes. In particular, how black holes interact with quantum mechanics and whether black holes are compatible with fundamental physical principles such as information conservation are still being actively researched. Another interesting topic is the merger of black holes. Two black holes usually form as a result of the supernova explosion of massive stars, and over time they approach each other and merge. This process triggers the curling of spacetime and the formation of gravitational waves. Black hole mergers have been detected by observatories that detect gravitational waves, such as LIGO and Virgo, and a new door has been opened in this field. Black hole mergers play an important role in understanding cosmic events in the universe. The general theory of relativity is a theory of physics developed by Albert Einstein that explains that gravity is caused by the curvature of spacetime. This theory plays a fundamental role in our understanding of the existence and behavior of black holes. According to the theory of general relativity, mass bends spacetime, turning it into a curved geometry. Because black holes have a large density of mass, their spacetime becomes extraordinarily twisted and warped. This curved spacetime determines the paths of objects moving around the black hole and explains gravity. The general theory of relativity explains the event horizon, one of the most important features of black holes. Anything that falls inside the event horizon is sucked into the black hole and never comes out again. The radius of the event horizon is determined by the mass and size of the black hole. Matter and energy inside the event horizon move towards the center of the black hole and condense. The theory of general relativity also explains how time changes around black holes. Time passes slower due to the gravitational force of black holes. This effect is called curvature of time. The slowing down of time around the black hole returns to normal as we move away from the black hole. The general theory of relativity also explains the accretion disks formed by matter orbiting black holes. Matter rotating around a black hole may emit high-energy rays and particles as a result of friction and collisions. This process explains why black holes cause bright and energetic phenomena. The relationship of black holes with the theory of general relativity allows theoretical predictions to be made about the behavior, effects and evolution of black holes using the basic principles and equations of this theory. Observations and experiments confirm that the general theory of relativity successfully explains black holes. However, the incompatibility between quantum mechanics and general relativity theory is an area where work is still ongoing on how black holes behave in the quantum field. The meaning of the event horizon is a concept that determines the outermost boundaries of black holes and affects the events around them. Anything that falls inside the event horizon can no longer escape the black hole and will remain inside it forever. To better understand the event horizon, it is important to first understand the general structure of black holes. Black holes have an extraordinarily dense density of mass, thus deeply curving spacetime. This curled spacetime determines the paths of objects moving around the black hole. The radius of the event horizon is determined by the mass and size of the black hole. An object that falls inside the event horizon can no longer leave the black hole because the gravitational force is so strong that it can even trap light. Therefore, anything that crosses the event horizon is sucked into the black hole and disappears. The speed required to cross the event horizon must be greater than the speed of light. However, since it is not possible to exceed the speed of light, nothing can cross the event horizon. Therefore, the event horizon forms the outer boundaries of black holes and defines a region from which escape from the influence of black holes is impossible. Significant phenomena can occur around the event horizon that are associated with a black hole. One of these is the accretion disk. The matter rotating around the black hole is arranged in the form of a disk as a result of friction and condensation. This disk can radiate energy and light around the black hole. It is currently not technically possible to cross the event horizon and study events inside a black hole. However, observations and theoretical studies confirm the existence of black holes and the existence of event horizons. The event horizon of black holes is a concept based on the theory of general relativity that explains the unique properties of black holes. To watch the second episode of the Black Holes documentary and access more scientific content, do not forget to subscribe to the Pursuit of Science channel.